Hey everybody, it's Mrs. Shevchuk here, and today we're going to begin our introduction to inequalities. So what we'll do is we'll start by reviewing the inequality symbols that you've seen before. We'll talk about what it means to be a solution to an inequality, and then we'll wrap up by writing inequalities for some basic real-world situations. Let's just take a quick refresher here at some of those inequality words that we use. So when we use this symbol right here, that is our less than symbol. We could read this statement as A is less than B. This symbol right here is less than or equal to. Other ways you'll see that is at most or is no more than. We also have the greater than symbol or the more than symbol. And then finally we have greater than or equal to, or more than or equal to. You'll also see is at least or is no less than. And you've seen these symbols before, so I'm going to keep us moving here. All right, so one thing you'll be asked to practice is write an inequality for a statement. So I'm going to read it and underline the inequality word that's in here, or phrase. So I see this: X is greater than or equal to 7. So I'm going to start with my X. And then I'm going to see down here my greater than or more than is going to be this symbol, or equal to 7. Okay, then I have Y is at most 5. You can look down here and see is at most means it's got to be that or smaller. So Y is less than or equal to 5, right? At the most, it can be 5, which means it has to be less than or equal to that. Part C says 9 is less than or equal to K. So I'm going to start with my 9 here. So 9, and then I'm going to use the same symbol, less than or equal to, and my K over on the right-hand side. And then finally D says X is at least -2. So I have X and I have -2. And then if something is at least something else, it has to be greater than or equal to that. And again, I can see that on my chart down below here. So keep that handy as you work through these today. All right, so another thing you'll be working on today is identifying the solution to an inequality. And so just a quick reminder here, the solution of an inequality is a value or values that makes an inequality true. So let's just kind of look at an example to kind of break this down. So for this first one, it says for each value of Y, determine whether it's a solution to, this is read as Y is less than 12. So is 11 less than 12? I can put this in and say, is 11 less than 12? Nope, we know that is not a true statement. So then is 12 less than 12? And nope, that is not a solution to this inequality. Is 17 less than 12? Nope, obviously not. Is 7 less than 12? Yes, that one is a solution to that inequality. What if I had something like -5? Is -5 less than 12? Yep, that would be also. So there's an infinite number of solutions. It's everything that's less than 12. For the next one, determine whether it's a solution to Y is greater than or equal to 9. So I just need to go in and say, well, is 10 greater than or equal to 9? Yes. Yes, it is. Is 9 greater than or equal to 9? Yes, it is. It's not greater than it, but it's equal to it. And so this is a solution. How about 14? Is 14 greater than or equal to 9? Yes, it is. And is 5 greater than or equal to 9? No, it is not. So you'll see some problems like that today too, and I think you'll cruise right through them. Another thing you'll see as you're working today is writing inequalities to represent different situations. So let's read through a couple of these. This says the temperature inside the lab refrigerator is less than 45 degrees. And they tell you to use T to represent the temperature of the refrigerator. So I want to say T is less than 45. All right, the distance to the nearest exit door is no more than 150 feet. And they tell us to use D to represent the distance to the nearest exit door. So D is no more than 150 feet. So no more than means that it has to be less than that, or it could be equal to that. So it could be 150 or it could be less than that. And then the next one we see, the vehicle's fuel efficiency is at least 30 miles per gallon, and we're asked to use F to represent their fuel efficiency. So if it's at least 30 miles per gallon, then F has to be greater than or equal to 30. And again, you can see all of the words down here on that little table. The cargo of the truck weighs at most 2,400 pounds, and we're asked to use W to represent the weight. So we want W to be at the very most 2,400 pounds. So that means it has to be less than or equal to 2,400. And to ride a roller coaster, a visitor must not be less than 60 inches tall. So that means if you can't be less than 60 inches tall, you have to be 60 or greater. And we're using H here to represent their height. So H has to be greater than or equal to 60, right? If you were 60 inches, you could ride it, but if you were less than that, you couldn't. The final thing you'll be asked to do is take a sentence and translate that into a one-step inequality. So here's a couple examples to give you an idea of what that will look like. So the first one says, the product of C and 9 is less than negative 29. So I know product means I'm going to be multiplying, and so what am I multiplying? C and 9. So instead of saying C times 9 like that, we don't want to do that. We'll do 9C because we know that in algebra, we always put our number in front of our variable, the coefficient in front of our variable. So we have 9C is less than negative 29. Right? Our second one says the sum of 6 and B is greater than 29. Sum tells me that I'm adding, so I'm doing 6 plus B, and that's greater than 29. And then our final one says a number B increased by 7 is greater than negative 22. So increased by means we're adding, so B plus 7 is greater than negative 22. And then later this week, we'll work on solving these inequalities and graphing them. But right now, let's just practice writing them from sentences. And that's it. That's what you'll be working on today. So hop into Alex, go through some of these problems, and let me know if you have any questions. Thanks for watching.